Ukraine reveals what's inside Russia's newest cruise missile. Ukraine's Military Intelligence Directorate has published a detailed technical breakdown of a previously obscure Russian cruise missile developed specifically for the Su-57 stealth fighter, revealing not only the weapon's architecture and capabilities, but the extensive network of foreign components — American, Chinese, Swiss, Japanese, German, Taiwanese, and Irish — that made it possible to build. The main Directorate of Intelligence of the Ministry of Defense of Ukraine, known by its Ukrainian acronym GUR, published an interactive 3D model component breakdown and electronic component base analysis of the S-71K Kovyor, translated as carpet, air-launched cruise missile on its War and Sanctions portal. The disclosure follows GUR's earlier publication of the enterprise cooperation structure behind Su-57 fighter production, extending the Directorate's systematic effort to map and expose the technological foundations of Russia's defense industrial complex. GUR explicitly called for strengthened sanctions pressure to limit Russia's ability to wage war, framing the component disclosure as part of that campaign. The S-71K was first used in combat by Russian forces at the end of last year, making it one of the most recent weapons additions to Russia's active strike arsenal. According to GUR, it appears to represent the United Aircraft Corporation's, known in Russian as OAK, first serious attempt at cruise missile development, a significant observation given that OAK is primarily an aircraft manufacturer rather than a missile design bureau. The weapon was developed specifically for the Su-57 Felon, Russia's flagship fifth-generation stealth fighter, creating a pairing between a stealthy launch platform and a newly developed standoff weapon that has not previously been publicly detailed at this level of technical specificity. The warhead configuration is straightforward but effective: an OFAB 250-270 fragmentation, high-explosive aviation bomb weighing 250 kilograms integrated into the structural load-bearing frame of the missile's nose section, using an existing proven bomb as the warhead rather than designing a purpose-built munition, reflects a pragmatic approach to what GUR describes as a first-generation effort, leveraging existing explosive technology within a new delivery system architecture. The missile body is constructed from multi-layer fiberglass-based composite material with additional reinforcement, while internal structural elements use aluminum alloys. The onboard control system includes a flight controller, an inertial navigation system based on basic sensors, and a power supply system. Propulsion comes from an R500 turbojet engine manufactured by Reynolds LLC, a company that falls within the United Aircraft Corporation structure, combined with a main fuel tank and two lateral fuel tanks. GUR assesses the S-71K's probable operational range at up to 300 kilometers, enough to threaten targets well behind the front line when launched from a Su-57. Operating at standoff distance from Ukrainian air defenses, the range figure, if accurate, places the weapon in the same general class as other Russian air-launched cruise missiles that have been used extensively against Ukrainian infrastructure and military targets throughout the conflict. The electronic component disclosure is the element of GUR's publication with the broadest strategic implications. The overwhelming majority of the S-71K's electronic component base is of foreign origin, sourced from the United States, China, Switzerland, Japan, Germany, Taiwan, and Ireland. That list spans the full range of the global electronics supply chain, from American semiconductors and Japanese precision components to Chinese manufacturing and Swiss precision engineering. Russia's ability to integrate components from 7 different countries into a newly developed cruise missile, despite more than 3 years of war and a comprehensive international sanctions regime, is a direct challenge to the premise that export controls and sanctions have successfully isolated Russian defense production from global technology supply chains. The weapon's intended delivery platform, the Su-57 Felon, is Russia's most advanced combat aircraft, designed with stealth characteristics, supercruise capability, and an internal weapons bay. Pairing the S-71K with the Su-57 creates a combination in which the launch aircraft can approach Ukrainian air defense systems at reduced radar cross-section before releasing the missile at extended range, complicating interception by compressing the available reaction window. GUR's earlier disclosure of the Su-57's production enterprise structure, published before this missile breakdown, provides context for understanding how these two programs are connected within Russia's broader aerospace and defense industrial system. Perhaps most consequentially, GUR notes that Russian planners are considering future employment of the S-71K from the S-70 Okhotnik Hunter unmanned combat aerial vehicle. The S-70 is Russia's heavy stealth unmanned wingman aircraft designed to operate in coordination with a Su-57, an unmanned platform carrying a cruise missile that itself carries a 250-kilogram warhead operating autonomously or under Su-57 pilot control at standoff range represents a significantly more complex targeting and interception problem than a conventional manned aircraft delivering the same weapon. Whether Russia has progressed that integration beyond the conceptual stage is not indicated in GUR's disclosure, but the Directorate's decision to flag it suggests they regard it as a credible near-term development rather than a distant theoretical possibility. The S-71K is described in earlier reporting as blurring the line between a drone and a cruise missile, featuring a swept-wing design, twin-fin, all-moving tail surfaces, advanced optical and navigation sensors, and onboard systems described as including automatic target recognition and AI-enabled decision-making processes. Those characteristics, combined with the warhead integration and turbojet propulsion, make the weapon a hybrid platform whose classification matters less than its operational effect. A standoff precision strike capability that Russia did not have 2 years ago, built partly with components sourced from the countries sanctioning it. GUR's publication of this level of technical detail, interactive 3D model component list, foreign supplier identification, is not primarily a military intelligence product. It is a sanctions enforcement argument presented in a format designed to give regulators, export control agencies, and policymakers in Washington, Brussels, Bern, Tokyo, Berlin, Taipei, and Dublin the specific information they need to trace how their country's components ended up inside a Russian cruise missile being used against Ukraine. The message is explicit: the sanctions are not working as intended, and the evidence is now on the internet in 3 dimensions. A cruise missile built by an aircraft manufacturer powered by a turbojet from a company called Reynolds, carrying a repurposed Soviet-era bomb guided by components from 7 NATO-aligned or partner nations, designed for a stealth fighter that may eventually hand the mission to an autonomous drone. Russia's defense industry is more resourceful than the sanctions regime has managed to stop, and Ukraine's intelligence service is making sure everyone can see exactly how.